Hi, welcome everyone. My name is Maximillian. I'm working for EclipseSource, and today I would like to talk about future modeling tools with Eclipse Theia. While preparing the talk, I realized that maybe the title should have been a little longer, because basically this is future modeling tools with Eclipse Theia and EMF Cloud. So what is EMF Cloud? EMF Cloud is a project at the Eclipse Foundation, and it's about providing reusable components for building tools, and in particular modeling tools. What do I mean by those kinds of tools? Those are tools that have a data model that describes something from your domain, like, for example, certain aspects of a car, safety. You have a data model that is not only standalone, but that's synchronized between editors that show different aspects of that data model. Usually those different editors are a tree-based editor to explore the structure of the model, a form-based editor to enter data and view properties of the model as in a form, a graphical editor to view interdependencies in a graphical representation, and often enough a textual editor. Additional functionality that's very common in those kinds of tools is validation, so to validate the data model, and diffing and merging to be able to version the data model. And the overall goal of EMF Cloud is to provide those components that you can reduce the initial effort as well as the maintenance effort for products that want to build such a tool. And last but not least, those components are also in production in different tools, so they receive industrial hardening. Where is EMF Cloud now? So EMF Cloud is a project that's running for a couple of years now. And the components that are available today is a model server based on Java and EMF. The model server is responsible for doing that data model synchronization between different editors. And it's also features editor support. So it features editor support for building tree-based editors with EMF in the backend, so the traditional EMF in the backend. Graphical editors with an integration with GLSP, the graphical language server platform, also with EMF in the background, and a form-based integration that uses JSON forms, which allows you to migrate from EMF forms, and a textual DSL integration via Xtext. Additional features that are available is an integration with EMF validation and an integration with EMF compare, basically covering exactly the feature set that I outlined in the previous slides. All of those, you can already see that heavily have still ties with EMF, which is basically very good if you have an existing tool based on EMF. And there's demo products available that showcase how you can use those components. One of those demo products I'm going to showcase today as well. It's called the Coffee Editor. It's about building a coffee machine. And there's also an eCore editor available as a demo product. The goal of those two demo products is to show you how to use those components in an actual product. So what is this talk about? There is something new that I would like to announce. So something was missing in EMF Cloud, and that's something we discovered over the recent years. The focus that we have so far is very much on reuse. So the idea is that you can take an existing tool that you've built with Eclipse RCP using the classic Eclipse modeling framework, and now you want to go to the web into a Theia-based application, and you want to reuse as much as you can, because you already have to rewrite much of the UI. So the goal was to reuse as much as you can from the data model and the synchronization and so on. But of course, that reuse also comes at a cost. It leads to compromise, especially if you have a greenfield project where you don't care so much about the migration use case. You get a mixed stack because you have JavaScript, TypeScript front-end development, but in the backend, you still have Java and EMF. You have more inflexible deployment options. You need this backend to be able to run those Java-based processes in a container. And last but not least, which is interrelated with the previous point, the backend gets quite fat because Java is using a lot of resources. And if you think about hosting Theia in a cloud-based environment, like for example with Theia Cloud or on Kubernetes, you have to run those containers on a per user basis. So it's really important that the backend is not that fat, because you will pay for the backend for every single user. So what are we about to do, and what's in the making for EMF Cloud? We are working on a second line of components for greenfield projects. So not with the focus on migration, but with the focus on what would be good if someone wants to build a modeling tool based on Theia from scratch. And this second line of components builds on a uniform TypeScript-based stack. It has quite flexible deployment options, which I will come back to later. And it can have slim to no backend at all. The status of that current development is that we have developed components that are in production, and we have generified those components for EMF Cloud. We are putting significant resources on this and will be continuing to do this. In Q4, we are in the legal release process, so we need to get all the legal approvals to publish what we already have. And in Q1, we want to have an official OS release at the Eclipse Foundation. So, having said all that, I would like to briefly demo what we already have. For people that have attended a previous talk about EMF Cloud, a little disclaimer up front, or maybe more an adjustment of your expectations. I mean, what we want to get basically is exactly the same demo that we had before, just underneath there is no Java and EMF anymore. So basically it will hopefully look very similar to the, and indeed it does, to the Java-based version that we already have. So I have a terminal here. I'm gonna launch a Theia application. I'm gonna navigate to the front end. So this is a regular Theia application. And in the workspace, I have placed a couple of files that are important for my demo. And one file contains this model of a coffee editor, and I can just open that up. That opens up in a form-based editor. So I can look at different things here, and I get the attributes of those items. And it's a tree-based view that shows me the structure of the model. I can also open that as a textual representation. So here I get a very JSON-like textual representation of the same thing. So that could be a textual DSL. In this case, it's a very generic textual DSL. And last but not least, we also have a graphical representation. And let me just place those side by side. So those are three different representations of essentially exactly the same data model. So here we have what we call a task called preheat. And if we go here, we can also see that we have here an item that's named preheat. And we can also see that this is available in the graphical editor. And those three editors now work on exactly the same data model. So I change that now to superheat. And I can see that I changed the ID to superheat. That was not clever. Okay, gotta reload that. Thanks to one of my colleagues who had the great idea to have the IDs and the names the same. So that confuses me a lot. Gotta adjust that for the next demo. So bringing up the three editors again. Let me briefly place them right to each other. And there we go. So here we have preheat again. This time we change the name, superheat, and we can change that see that the name changed here, and it also changed down here. So the change propagates, and well, obviously I can do the same. So I can go to a different one like brew and go to the name just to be sure. Change that to super brew, right? That also works. I can also do a change here. So I could add a new automated task, add it to the diagram here, rename it to pause, and that should also be available in the textual editor. So let's just search for that. Yeah, we see it here. For the new items, as a side note, we have proper IDs here. So that works. And if we look to the tree, if we can see that, here it's also the pause element is available. So that's a basic structure that still works in the new version of Theia and EMF Cloud. So how does that work now? Because the architecture is a little bit different for that second line of components. So what we changed is, or what we just saw is, we have a centralized editor access via something that we call a model hub. So all the three editors that we have seen connect to a model hub. What's a model hub? The idea of the model hub is to have methods to interact with the model, with the data model. So with the model hub, you can load, get, and save a model. So loading means loading from persistent storage. Getting is getting the content of the model or partial contents of the model that you want to display in an editor, and save is obvious. Then you have methods to read and write to the model, because you need to be able to issue changes to the model as an editor. And you can also subscribe to the model so that you can update your editor in the face of changes of other editors. And finally, you have undo, redo. So there is something like a command stack in the background. There's some more optional methods. So the ones that we saw before are mandatory. Those are optional. There can be methods to resolve references if you have any. You can validate the model if you have any validation. And last but not least, you can also add your custom API to the model hub, which can be useful to provide domain-specific API. This architecture is modular. That's also a learning from the first line of products. We want to compose a model hub from different capabilities, and those capabilities are now can be seen on the right-hand side. And the reason for that is that you can then choose different technology, choose and combine different technologies to implement those capabilities. So we split that up into persistence, that's loading and saving. Editing domain, if you're familiar with EMF, you know what it is. Basically, you can get the contents of a model, you can change a model, and you can undo and redo. You can have optionally a capability to resolve cross-references and a capability to validate your model. And you can have your custom API, as mentioned earlier. So how does that work with facilitating reuse? Those are actually combinations that are in use in products that we have created. So for persistence, you can, for example, use Langium, which basically is it's a new version of Xtext, if you're familiar with Xtext. So it's a textual language framework. Then you persist with the grammar of your textual DSL, which is often useful because then it's also human readable in its text form. Or you can have your custom implementation. So for example, we have custom implementations that serialize that as JSON or XML. For the editing domain, we provide in EMF Cloud an implementation, a JSON patched-based command stack. For cross-references, you can, again, use Langium for resolving, as well as for validation. For validation, we also alternatively used AJV, which is a quite popular JSON schema validator. And of course, for your custom API, you just need to have a custom implementation. For the coffee editor that we have just seen, how is that constructed? So for the coffee editor, we use Langium for persistence, cross-references, and validation. We have seen that we have this JSON-like syntax that is very close to JSON, but it's based on a grammar in Langium. We have, for the editing domain, used the JSON command stack that also ships with EMF Cloud, and we have some custom API, for example, to create tasks and link them with other tasks. So how does the architecture of the coffee editor now in more detail look like? We have this tree editor that we have seen, where I select a node, and then in the detail, I get a form. we had a GLSP-based editor that was the graphical editor, and any GLSP-based editor always consists of a front end and a back end, where the front end, following an LSP-like approach, is rendering the graph, and the back end is mapping the graph onto the semantic model. And we had a Monaco editor, which was the textual editor that we have seen, which is the editor that's also used in VS Code for coding, basically. Then we have the model hub, as we discussed, and unsurprisingly, the tree editor and the GLSP editor connect to the model hub for some strange reason. The Monaco editor doesn't do that. We'll come to that, back to that in a second. Then the model hub is using a coffee model contribution. So a coffee model contribution, if we recap, that makes available all the capabilities for a certain model. So in our case, for the coffee model, so the capabilities of persistence, validation, cross-reference resolution, and editing domain, and in our case, also a custom API. So the model hub will delegate to that coffee model contribution to be able to deal with the coffee model. If you can have a model hub, or that's actually really desired, a model hub can deal with multiple different kinds of models. So you could also have a model hub that has a coffee model contribution and an eCore model contribution, if you have such a model. The coffee model contribution uses the JSON command stack. So if the tree editor does a change, effectively it ends up on a JSON patch-based command stack. And the coffee model contribution also uses Langium, as we've seen on the previous slide, for persistence. And now finally, this riddle is solved. The Monaco editor, since it talks LSP, can connect directly to Langium and doesn't have to go through the model hub directly. And then in the end, Langium persists the model as this textual DSL into the workspace. So if we look at a round trip, if the tree editor wants to change something, it goes to the model hub, and eventually it has already loaded a model. It has retrieved the contents of the model. Now it wants to change something. It will call a method on the model hub. The model hub will know that the model that was loaded with that URI is a coffee model. It will therefore know that it needs to delegate to the coffee model contribution, depending on the method. In our case, a change. It will have to delegate to the JSON command stack. And the JSON command stack will then execute the command and communicate through the model hub to Langium, for example, to update the persisted model. And then maybe at a later point, the tree editor calls save, and Langium will persist that to the workspace. And also the model hub will, like the GLSP editor, for example, is also subscribed via the model hub. It will update the GLSP editor and tell it that something has changed and that the GLSP editor can now update its model to reflect the change in its UI. Deployment option, I promised that earlier. So with the first line of components for EMF Cloud, there was always a Java process in the backend that needed to run in a container. Now we're much more flexible because everything is TypeScript. So we can do the classic deployment, just deploy the front end editors into the front end. But we can now go a step further. So GLSP also supports to just run the entire editor in the front end, including the backend, which is counterintuitive, but makes a lot of sense. So then you don't need to run that in the container anymore, the backend. You can go one step even further and say, okay, the model hub, so the synchronization of the editors, as well as the coffee model contribution and the command stack, they all run in the front end. And basically only the persistence through Langium is still in the backend. And then, of course, you could also pull Langium in. Or for that matter, you might have seen the talk of Stefan on backendless Theia. You can just pull in the entire workspace into the browser as well. And that gives you a lot of freedom. That could even be something you do dynamically. So if you have the requirement, for example, that you want to be able to run as cheap as possible, so you don't want to use backend resources, but you need to maybe at some later point have users that have large models that don't fit into the browser front end anymore. If you have that requirement, you can offer the users to have a flexible deployment option where you change the deployment and more of the components run in the backend so that you can work with larger models. incurring more cost, but also giving more power. So you might now ask, and I apologize already that I have to give the typical answer, but trading off now between the first line of products and the second line of products, there's different arguments that you could follow, and different dimensions. And based on how you judge those dimensions for your specific product, you get to a different result. So for example, if you have a lot of existing code, you probably value that existing code and you have to weigh that off over ease of development, right? Because the existing code is Java-based code that interacts with EMF, and then you will have front-end code that's in TypeScript and JavaScript. But if you have a lot of that code, it might well be worth to just keep the code and then not have a uniform stack. Same goes for the migration versus deployment option. If you want to be able to migrate existing stuff, you're less flexible with the deployment options because you will have to have a container that runs many of those processes. And same also goes for features versus slim footprint, because what I have to admit is with the EMF Cloud first line of products, we leverage the entire EMF ecosystem, which is huge and was built over more than 1 decade. So definitely there is more very specific modeling tool features available in the EMF Classic ecosystem. So in the end, this is a very tool-specific trade-off that you should definitely consider with care. So in summary, what I reported today is that if you build a modeling tool with Theia, you might want to consider EMF Cloud. EMF Cloud already has a first line of components that helps you a lot to migrate existing tools to the cloud based on Theia. If you have a greenfield project, you might now want to consider the second line of components, which is much more geared towards greenfield project with a uniform TypeScript-based stack with flexible deployment options and with, as I've shown, slim to no backend. What I maybe failed to mention is also, since everything is now TypeScript-based and you only have a Node server, that also tends, even if you have a classic deployment with only the front end running in the browser, the backend tends to be smaller. This is based on components in production, so it already has some maturity. We intend to release it in Q1 2024. We're still in that legal battle to get it out. But if you're interested now and you need to get somewhere, we can definitely also explore early access options. More information is available on the website. There is no update yet about the second line of products. I think that will come around Christmas. If you have any questions on that, please contact me. My name is Maximillian. My email address is here, and I'll also be in Swapcard, so you can contact me or one of my colleagues of EclipseSource. And with that, thank you very much. If you have any questions, please go ahead. I think we have a little bit of time left for questions. So the first question is, are there any plans to migrate from Xtext integration to Langium? For the first line of products, I guess, because the second line of components is based on Langium. For the first line of products, there are no immediate plans to migrate there from Xtext to Langium. If you're interested in having that, let me know. What needs to be written manually for the model hub to function, i.e. what else needs to be developed from scratch apart from the source model, Langium grammar, how are incoming changes from the model hub transformed into the Langium managed document edits? Approximately how slower is those fat EMF backend in comparison with the TypeScript-based stack? Okay, many questions. So what you need to write manually also depends on what you want to reuse. If you want to use Langium, you have to develop this grammar. You can reuse an existing grammar that we have that produces a JSON-like syntax. Apart from that, yeah, you can basically, if you want to, as soon as this coffee editor is available, you can use that as a blueprint. And to get started, you don't have to write a lot of code if you just use exactly the same components. What you definitely need to write is your custom API if you want to have any. And if you have, you need to write your editors. They probably deviate from the editors that we have. How much slower is the fat EMF backend? Well, slower is probably the wrong, at least I can't comment on slower. I don't think slower is really the right way to look at it. The problem with the backend is fat in terms of memory. So I know that the coffee editor that we have currently deployed on Kubernetes to run decently, it uses around 2 gigabytes of memory. And the version of the coffee editor that we have running now uses around 300 megabytes of memory. So almost an order of magnitude less memory. And most of that is contributed to Java. And probably you can still optimize something there, but I don't think more than maybe 50%. Okay. Any more questions? That's it. Okay. Thank you very much, and feel free to contact me anytime. I'm looking forward to discuss with you.